back, guys, to the T&G show. Have you ever been in a situation where you have a sample that you want to build a quantitative method with, but you don't have standards and it's dirty?
But like standard addition.
Yes, today that's what we're going to talk about. We're going to show you how easy it is to create standards for your XF analysis. So what is involved in building a calibration curve? First thing you want to do is you want to identify your ICP standards of interest, and then this is what you're going to do to spike into your standards. We also have mixing vials here that we want to put your base material in to create your calibration curve. So the first step that you want to do is to weigh out your base material into these mixing vials so that you can spike your ICP standards in there to make your standards. And you want to do this consistently for each of your standard into the mixing vials. Okay, now that you see we've weighed all your base material into the mixing vials, the next step is to add in your standards. But what I would like to do first is to make a little well or divot inside the material so that you can spike directly into that.
Oh, so that'll keep all that solution away from the walls of the container.
Exactly.
Okay, cool. So you'll not lose any material. Oh, so now, Ton, when you spike those in, and so you're going to be spiking in all different concentrations in each of those for each of the metals.
Exactly.
What if that acid in there will react with your base materials? Is there something we can do to get around that?
Oh, that's a great question. What you can do is get some kind of binder, cellulose in this case, spike it into that, dry it, and then from there you can take that spiked binder and add it into your material.
Okay, so you're already getting rid of the acid. When you dry it down, you not have to worry about
Exactly.
that. All right, and most people use binder anyways in their pellets.
Exactly.
All right, perfect.
Right, now that we have our standard spiked, the next thing that you want to do is to put it into the vacuum oven. So ours is set at 65 degrees, so depending on the volume that you spike into your standards, it could take a little longer to dry, but you want to make sure that it's dried completely before you move on to the next step. So the next thing that you want to do is you want to put it into a mixer mill. On this video here, you're seeing that's in a slow motion because we want to show you that it's very important that you homogenize your sample before you press it into a pellet. And then the next step you want to do is to press the pellet, and we're showing you here the pancake press method that we did previously.
All right, so we have another video on, they can check it out, right?
Exactly.
All right, make sure you go on a T&G show and look at it. Okay.
Okay, now that we have our standards pressed, what you want to do is to load it into your sample holder, and we're going to create a calibration curve.
This is on our tube above. Of course, we have a tube below too. We have a benchtop system that has a separate cup. Okay.
So once you create the calibration curve, you should see a positive intercept because your material has those base elements in there, and then you had added those extra standards in, hence the standard addition. So
especially if your base material was really dirty, you're going to see a higher positive y-intercept.
Exactly.
Or a lower one.
Exactly.
And as you can see from this fly up here, the that x-intercept we see from the dashed line is the base amount then of their sample, right?
And then what you would want to do is you want to take that amount and add it into your calibration curve to adjust it.
Right. So what they can see here in this Excel table is that we're adding that then that we call it a D value or the x-intercept to all of the standard values in that set.
Right. And you want to make sure you want to do it for all those elements that you've spiked in. Okay,
great. And so then now what we're showing is then what we've adjusted that calibration, and now here you can see because it's adjusted, it goes to the y-intercept, goes to 0, right?
Right. Now that once it's adjusted, once you run your unknown sample, then you will know exactly how much was in there. So now you're ready to run your unknowns against your calibration curve. It was simple as that. Hope you enjoyed our video. Let us know what you think, and remember to click the like button.